Hi, my name is David Zarnest, and I'm a Senior Product Architect on the oecloud project. Today we will be discussing the reliability of oecloud. The goals of today's webinar are first to discuss reliability in general and to define what it is, and then we will be discussing three features of oecloud that increase the reliability of applications built on oecloud. Those are idempotency, failsafe mechanism, and the async service. And we'll define each one, explain when they're used, and show a short example of how they work. Let us begin. Reliability in oecloud. So what is reliability? Reliability is an attribute of any computer-related component, software, hardware, that consistently performs according to its specifications. So to say that in more simple English, basically having an application that does what you think it's going to do in a reliable manner. oecloud offers three levels of functionality that can be used to enhance reliability. As we mentioned, the first is idempotency, and that's used for message reliability, which basically means being able to send messages, and perhaps multiple times, but without changing the actual results of the system. And we'll give an example and show how important that is. Secondly is the failsafe mechanism, which is used for functional reliability. Certain situations where there are parts of the application functionality that will have to be replayed in order to make sure that it happens. oecloud will replay them to make sure that they will occur. And thirdly is the async service, which is a send and forget mechanism. Certain times you have applications, certain features that require a very long computation time, a long time to get a response. So we don't want to have to write an application that will wait for that response. We could send it onto the async service and basically forget about it and check back later to see what the results were. This is something built into oecloud, and we'll see how that works too. So let's look at idempotency. So from a RESTful service standpoint, for an operation to be idempotent, clients can make the same call repeatedly while producing the same result. So in other words, making multiple identical requests has the same effect as making a single request. So by default, oecloud-based files are idempotent. So we'll give an example here, in a word example first, to explain this in a more deeper way. So let's say you have an application where the user is trying to execute a funds transfer between two accounts. So sometimes, as occasionally happens, you're sitting at your browser, press the send button, and after pressing the send, there could perhaps some temporary network problem, and no response is received. There could be a number of reasons along the chain of why that occurs, but you press the button and you didn't see really any response come back. So often, the user will just press the button again. And now, if in reality the first message didn't really go through, just for whatever reason you didn't see the response, you didn't get the response back, so you could run the risk of basically sending a transaction twice and maybe making two fund transfers. So by default, oecloud handles that situation, and only one transfer will occur. The user will receive the correct response, whether it was sent the first time or not. The user will receive the result of the actual transfer only once. Now let us see an example of idempotency. So on a local machine, we have an oecloud instance, and we'll show you through the Swagger interface how idempotency works. I have created a model called inventory that has the following additional call besides all the regular CRUD calls. It's called add items. And what add items does is that it takes the ID of an inventory item, and in the arguments that we send, there'll be the amount of an inventory balance along with a version. Now what happens is, in this call, when we send this data, so the balance that we send will be added to the current balance that exists in the database, provided that we have the correct version number that we send. Now, the correct version number is one different than the one before. So let's try that. If we have, as an example, Let's just do a show what we have in the database right now. This is in ID BBB of the inventory item. We're looking for the balance of 716. So if I add 11, and we'll up the version number by 1, and execute that, see what happens. Goes up to 727. Right, so that's basically what we thought would happen. If I execute that again, as the example that we gave, let's say I had not received a response, and I press the send button again, basically the same response comes back. It's the same balance, and everything all looking the same. And just every time that I increase the version number, then the balance will go up. That's a 738. I also would like to show you that in code to see what that does. Here is the inventory model part of it, and here's a remote method that we added called add items. That's how you add a remote method. And inside the function, just to show you, we get as parameters the context, which is the parameters that we sent along the request. Then there's options that get sent in. That's it for system internal use to pass along database calls and plus callback. So as you see in the code here, we take the balance that came in the context, we add it to the current balance that exists, and then we build a JSON object that includes the balance and the new version number, and we update the database, update attributes. On the return call, as you saw, that was printed out, new balance is the balance that we have. Now, internally, inside of oecloud, we could see that if we have the same version number sent in, it will return, right, the same without any error, right, otherwise you would get an error over here, same new balance coming back, and that's all internally handled in the in oecloud via idempotency. Now, just also would like to point out that idempotency is something that's besides beneficial use for in the client-server situation, as we've described. We internally use idempotency in many areas of recovery, where different parts of the system, upon recovery, certain messages are replayed internally between components, and we rely on idempotency to make sure that even though we may replay some of the messages again to be extra sure, it's not going to change the status of the data inside. So that is idempotency. Okay, let's move on to the failsafe feature. So oecloud-based models have an operation hook called afterSave. Basically what that means is that after a model is saved or updated in the database, so a function is triggered within the server code that basically can allow you to do more operations, more things after the model is saved. We'll give an example coming up about where this can be very relevant and very important. But the issue is that when a client will post an update to a certain model, so regarding the post itself, the client will receive an OK, a code 200 from the server, and he thinks everything is fine. And this has nothing to do with the code or the procedures that are going to be done in the afterSave. And perhaps those may or may not be successful. The user may not know about it. So oecloud built in a mechanism where these functions in the afterSave will be called over and over again until they are successful. So in this way, without any extra code, so the user, the client, and also people on the server could assume and know with a surety that these items will occur, and the user will receive his 200 code, and everything's fine from his end, and the work on the server will continue guaranteed without any extra coding. So now let's look at an example, a word example, where this can be very, very important. So let's say we have a certain system where, I guess for governmental reasons or for other reasons, anytime there's a $10,000 change in a certain account, let's say plus or minus, so the bank must send an update to an external governmental system for reporting purposes. Now, we don't want to condition the success of the transaction on the success of whether or not the report occurred, because basically we want to have the control, and we do have the control, of the transaction in our system, and it just really doesn't depend on the fact that it has to be reported, but nevertheless, the report must happen. So how would one go about assuring this? So one way would be to use this after save capability and basically have, after the transaction is saved in the database, so in the after save of the model, say of this account model, so then we can then shoot off a message to some external reporting system, and the report can then happen. And even if, let's say the system would be down for a moment, some other problem, it would fail. So without any extra code, oecloud guarantees that this will be recalled until successful. oecloud will make sure that it happens. So now let's take a look at a real demo. Now we're not going to talk about this account demo, but we're going to continue with the inventory demo that we started with before. And after that, I'll also show you in code how this all looks. So if we go to our demo, we're going to use Node-RED to demonstrate the failsafe capabilities. Node-RED is a system that we've integrated into oecloud, and it's basically it's a visual way where we'll be able to show you the feature. Basically, anything that's done here can be done in code, and again, I'll show you later in code where the after save really is. But first, let me describe what we're going to try to do, and then I'll show you what's happening in the Node-RED. So if we go back to our inventory item in our local oecloud system, so again, here we have our post, and if I do another post, I'll show you where it's going to go on the reporting side. So up that to 38 and execute, and bounce up to 760. Now we have a remote system that I've put up here, something called integration system. And if you take a look here, legacy inventory item, and this is where we're going to be posting our reports. So if we take a look and just execute what's there in the get, we see that the post we just did of 760 appears here in our remote system. So this is all happening via the Node-RED. So let's now take a look at that. So in the Node-RED, we could have a node called legacy sync, where we could talk. This is the integration with oecloud. We put a model name here, which is our inventory model on our local system, and the method of what we want to get called on is after save. So whenever a save occurs in the inventory model, this Node-RED flow will get executed. In this flow, we basically look for the inventory balance in various parts of the data that's being sent. And we take the inventory balance, add it onto the message in Node-RED, which flows from node to node, and then we actually have our call to update legacy. So let's take a look at that. That's a post to our integration system far away, and it will post to the legacy inventory model. And that's how we saw that happen. So we basically, this will be relevant for our test coming up. We check the response, and if there are any errors there, we'll post our own error. And otherwise, we end the flow. And this message payload here is just showing us the output. So this was a successful post that we just did. As you can see here, this 760 balance came, and as we saw, it showed up in the system. So now let's look at the following scenario. I am going to bring down the service, that's our legacy service, and then we're going to see what happens. The way we scale down the service is as follows. We're using Docker. Our oecloud, in a full sense, runs in a Docker environment. So this would be the command, sorry, for the scale down. Docker service scale, integration web equals 0. So let's bring that down now. So that was that our remote integration service is now going down. So if we now try to do a post from our local system, let's see what happens. So here are the local posts. We're going to now go one higher and post another inventory, execute, and totally successful. 771, the transaction happened. Very nice. Now I take a look at Node-RED, and on Node-RED we see the following. It's trying to post as it was triggered here on the after save, but we see that there's a 503 error, and because the service is not available. So the report did not happen. I'm not going to do the, if we would try to rerun this, basically the whole screen would go blank because, well, let's take a look anyway. Might as well try, execute, and, well, yes, we got the same error. So nothing got posted. So that part did not happen. So, however, if you take a look, as that another one printed out that because the oecloud is retrying without, there's no code here written for the retry. This is all internally happening in oecloud. This after save trigger was not successful because we threw an error in this check response, right? As again, right, hit an error 503, node error. So that's how our system knows that it did not successfully complete the after save. So it keeps replaying it. So now we'll go and scale back up, right, put it back to 1, and we should soon see, assuming it gets up in time before the next retry, or if not, there'll be another retry after that. But let's take a look. Now, by the way, while this is happening, I'll just show you the configuration of how often and how quickly these retries occur. It's just all configurable within oecloud, so I've still got a service down. Let's erase them for now and we'll wait for another one. But I'll show you in the interim, in the code itself, in the config of the server, that there are a bunch of variables, configuration variables, amongst many others in the system. But here, this is called event reliability, and we set the replay interval to that is 30 seconds. And that's why they're happening in a little bit of a slow way. But by default, they're lower numbers, but they could be set in any situation, basically as per the needs of any particular system. And here we see, and now it was retried again, and finally it did succeed. And if we go back to the remote system and do the execute now, we'll see that we have now two posted records, the 760 and the next one for 771. So this was an example of the oecloud failsafe mechanism in action. And as also as I promised, I just want to show you what a failsafe looks like in code. So if you just take another model we have, which is the base model of our inventory model, obviously the code of what we just did is not written here. That was all done in Node-RED. But I just want to show you what an after save looks like. You basically have the model, and it's observing the model, and after save is what you are observing, and then a function gets called, and you could do anything in here. And in our example, we did that remote call to the system, and you could have all done that all in code here, and looked for the response, and if there's a response, throw the error, and it all would have happened in here too, but we just showed it in Node-RED as a more visual way. So again, that is the successful show of the failsafe mechanism. Now let us describe the third feature for reliability, the async service. As we've said before, basically the async service is a send and forget service. You have certain actions that take a very long time to compute, or certain long queries in databases. We don't really have to have the client wait for the response. It's not very user-friendly. So we created in oecloud a standalone service that wraps around oecloud that allows us to send requests to the service, to the async service, and receive an immediate response, which is basically a pending ID. We'll take a look at that in real life coming up. With that, the client can go on and at some point later on check with that ID against the original service that it sent to see what the status is of that request. In the interim, the async service of oecloud will guarantee that this URL is replayed over and over again until it is successful. So it's actually a combination of like a retry mechanism and a send and forget service. We have here a diagram of what this is really based on. Its core, it's a RabbitMQ implementation, along with the processes all around it that will feed the queue and read from the queue. So as you can see coming in, it's HA proxy is our proxy entering into our swarm. Number one, regional request comes in, and with a special URL that we will see, it goes to the async server. The async server checks with the service that is supposed to be servicing this request to see if indeed the request is retriable. It has to have special properties for that, and we'll also see that in the code. Assuming it is retriable, so then it will be initiated, and the response will be sent back to the ASIC server with that ID, and the ID will be passed back to the client, and the client can go on. Now, internally, inside this async server, so the async server will post it to the queue, and from that queue, again, all configurable time-wise, how often something's coming off the queue, but we have a queue reader, or async processor, who's reading off the queue, and number 6 consumes the messages, and then it sends it the original URL that's supposed to go to the particular service that will service it, sends it there, and it looks for the response. If the response fails, it'll go back to the queue and go again, standard queue. When it succeeds, basically it won't go in the queue anymore, and at that point the client can keep checking. Eventually we'll see that it did succeed. If eventually it goes a number of times, configurable, eventually if it keeps failing, it will go to a dead queue, and it can be seen over there. So in a nutshell, that's the overall design of the async service. So here, let's give another word example of where such a thing will come in quite handy. If we have previously delinquent customers, where in order to allow, I guess, a transfer or a withdrawal, they require additional checks against an external credit company before we can allow any transaction to occur. And in this case, this ends up being an integral part of the transaction, because if we get a negative response back from the external credit company, we will not allow the transaction. But at the same time, this is something that may take a lot of time to get that message back from the external credit company. So what's a way that we could do this without making the client wait and keep it all user friendly? So the ASIC service in this case will be a good solution, because by sending this request to the async service, so the client will get the immediate response with an ID, which you could use to check later, and then the async service will try to run the URL on the queue. Again, if it fails, it'll be retried. So this is a pretty good example of where we would like to use the async service. So now let's go to look at a demo of the async service. We again will not talk about the demo we just spoke about with the delinquent customers, but we will continue with our inventory management example from before. So here, let's see how it works, the async service. Okay, so let's take a look at what we would like to do in this demo. So on our remote service, I've created another call that's called heavy computation. This call is meant to take a long time. It's going to read a whole bunch of records in a database, do a whole bunch of heavy calculations. For our purposes, ultimately, we would like to see another record written out into our legacy inventory that presumably would be some kind of sum or something, right? As you can see here, we already have 2 records, so we'd eventually like to see a third. So this is the call that we would like to be sending through the async service. Okay, so how do we do that? So taking a look at some of the documentation. This is the way a regular post would look into oecloud. And now you have your name of your oecloud service. And this is a REST call, a standard REST call with a model name and the access token, fine, and whatever, any of the data that you would want to have. So if we'd want to make the same kind of call to our service that we think will have a request that takes a very, very long time, so you would send it to the async service just by replacing the original URL of your service with the async service, the URL of that, and then everything else being exactly the same. You see here the same model name, and the instructions tell us that you have to add another header called xhost, and that host is the ultimate endpoint service of where originally the request was supposed to go. So in this case, if it was my service, as you see here, we add another header called xhost my service, and with that, that's how the async server will know, okay, when I have to send it to the endpoint, he uses that header and will send it to the right place. So that's all you really have to do in order to send something to the async service. Now I just want to show you something else in the code. We mentioned about the fact that there was a property on the model that makes something retriable. So if we just quickly try to find our legacy inventory.json, so you see there, we added one of the mixins called retry support mixin, and with that mixin, that's the way we know that this is retriable. When this model is queried, it will say yes, retriable works. So in order to have a model be retriable, you do have to add that mixin into. So that's yet an additional step that you'd have to take. Now let us take a look at the actual invocation of the async service with our request. So I have a file here that I prepared the request, and basically you see we are calling the legacy inventory model with that heavy computation process that we added, and it is being sent to the async service, and the ultimate host of where the service really will run is here, our integration remote model. So if we execute this, we hope to see basically an ID come back, and then we'll be able to see the process and see what happens. So let's try to run that and get the ID. Okay, there is the ID. So now, okay, this is being sent into the queue. So let's take a look at our rabbit queue. And here you see on this chart over here, the message has come in. And soon we'll see that it actually got queued up. All right, there it comes. And it goes right off the queue basically, and it gets executed. But it did go in and go out. And now basically we could check the remote service to see what happens. So let's go back and get that ID here, because we're going to do a query to see that the record actually has been created. So again, not necessarily would it be, it could be that it would not be there, because if this is really long running, we just have this ID for future checking. But in this case, basically it hopefully ran already. So let's take a look back here and go to our this is our legacy inventory. We're supposed to create another record. We're going to do just a get by ID to see that ID model. We'll see either it came back or it didn't. Let's see, and comes back, and there it is with that ID 212. That ID, it did create the other record. It's supposed to be long running. Okay, so this is the long run, and you checked it later. So that has been the a successful view of the retry queue, the async retry queue. And again, as if it would have been unsuccessful in for whatever reason, sending getting in touch with the remote server, or the computation would be, if it fails in a normal way and with a normal error, that's really a success with an error. But if there's some kind of overall error in terms of connectivity, or retriable error, network and stuff like that, so the message then will go back onto the queue and be retried again and again based on configuration from the queue to the service. So that again, that is the async service. Finally, let's discuss some of the differences between these last two reliability features, the failsafe and the async service, to discuss when one would use one versus the other. So let's go back to the PowerPoint and go Right. When would I choose one versus the other? Since they both offer retry capabilities, so when is one more appropriate versus the other? So as we've mentioned before, the failsafe mechanism was the one that works in the after save. After an update happens to a model, the ability to call functionality in an asynchronous way. So there, as we gave the example before, it would be appropriate to use the failsafe mechanism when the initial part of the transaction is something which is more in our control, and we have the ability to say whether it immediately succeeded or failed. So there's no issue of having the send and forget mechanism in place. And there, the secondary action is something where it has a high probability of success. Because there, we are not really using any external type of software like queues, like the rabbit queue. It's sort of built in internally into OE to do the retries there. So it will happen in a very secure way, in a very guaranteed way, but it's only on things basically that have a high, it's worth using that on situations where there is a high probability of success. As opposed to, we said, the async service. So there, again, for the issue of the slower transactions, as we've said, we're even the initial part of our transaction is not something which is really in our control. We have to get approval from somewhere else, or something where this, just takes a very long time in general without worrying about approval, just a long computation or long database processing. So as I said there, you might as well take advantage of the capability of the send and forget. But also, even when you have that, the process that's taking a long time or going externally, if the chance of probability is less, maybe dealing with some old legacy system that's not always up, not always available, or the situations, where maybe there isn't 100% availability or much less than that. So it would be more appropriate to use the async service there, because we basically are using a wrapper around the OE service, where there's a lot more overhead there. That overhead though will be more appropriate for something which requires a lot of retries. That's basically what a queue is all about. So in a situation where besides the send and forget, or even without the send and forget, it's something though that is something which has a less guaranteed probability of success, a lower probability of success, we would see it's much more appropriate to use the async service. So that's the basic differences between these two reliability features. So at this point, we'd like to open it up for if there's any questions that people have, we'd be happy to answer.